Every couple of years, I was about to say, and then I realized it's every couple of decades, I get really excited about a subject. So I've been working in startup technology for 20 plus years, 24 years now. And a couple of years ago, I got excited about a really, really interesting subject that nobody really talks about much, and that is manufacturing. Now we say, oh, manufacturing, it's like this boring stuff, right? You know, where people assemble things. But I'm talking about additive manufacturing. You all know it under the word 3D printing. Now, 3D printing, you think, yeah, that's the stuff that my daughter or my son do in their kids' room, you know, with their plastic printers. No, I'm talking about big industrial machines that produce a surprising number of parts that we use every day already. Now, to understand the full potential of additive manufacturing, you have to realize, you know, how is it different from traditional manufacturing? And so I want to talk a little bit about, you know, how we do it today. I mean, basically, manufacturing hasn't really changed that much since we invented the first tools, you know, 1.5 million years ago. You know, we basically start with a big block of material, and then we remove everything that we don't want there, and then we kind of connect it to other stuff, and then we have a machine. I mean, this is kind of how Michelangelo created David. When he was asked, you know, how did he create David? Well, he said, easy. I removed all the marble that wasn't him, and then I have my statue, right? Okay, easy for him, maybe not so easy for us. But that essentially is how we still manufacture objects, right? You know, the first stone axe was created that way, and your car is basically also created that way. So if you manufacture stuff that way, complexity is your enemy, because every hole that you drill and every feature that you create costs additional work and additional time and additional money. So you try to keep things simple. That's the reason why most of the stuff around us is actually pretty simple, right? Even in a beautiful room like that. And beautiful things, you know, are usually very expensive. But that's not the only stuff that's around us, right? You know, there are other things around us that are surprisingly complex. I'm talking about the natural world. I mean, if you think about this tree here, it's unbelievably complex, but yet it is also extremely efficient. It used the absolute minimum amount of material and the absolute minimum amount of energy to produce the perfect tree for this specific location. Now, the interesting thing is, you know, how does the tree do that? You know, instead of removing stuff, the tree actually puts just the atoms in place that it needs to build its structure. Now, the interesting thing is, additive manufacturing works exactly the same way. It just puts the stuff in place that it needs to build the structure, and complexity is more or less irrelevant, because the printer doesn't care whether it prints something simple or something complex. All it cares about is actually how much material does it need. Now, this is revolutionary if you think about it. Right now, we care very little about how much material we need, as long as we can keep things simple. Only when we have kind of optimized our product to a certain extent, then we try to also minimize material use by maybe drilling another hole or whatever. In additive manufacturing, you don't care how complex the object is. All you care about is, you know, how much material do you actually use. So just for reference, you know, this is a sculpture that a good friend of mine, the London-based artist Andy Loomis, created. It's a digital sculpture. It's a 3D object. Printing this object here costs exactly the same amount of money than printing a cube that weighs the same amount. I mean, think about this. This is completely game-changing. Now, you may think about the materials that you probably associate with 3D printing, and I can tell you that you're wrong. So most people think of plastics and brittle plastics, and you know, it's not really usable for so much. You can print with almost any material out there. You can print with metals, you can print with ceramics, you can print with glass, you can print obviously with polymers. Here is the process of printing out of high-strength steel. You can print with copper, titanium. So you can print with concrete. There's actually a project here at the Nanyang Technological University about printing with wood-like material. So that would make printing stuff very sustainable. There's another project to print heart valves out of living cells. So why living cells? Well, if you print the heart valve out of your own body's cells, then it obviously won't be rejected by your body. It's very compatible. So really, I mean, the sky is the limit. And there's basically 3 different ways of printing things, whether you print with concrete or whether you print with plastic. In terms of the general process, it's actually not that different. Now, you're probably thinking of static parts. So, complex things that are static. But in fact, actually, you can print entire assemblies. So if you print a complex thing, I mean, why shouldn't it move, right? I mean, here are some really simple examples of stuff that come out of the printer like that, fabrics, etc. So you can print entire gearboxes. There are projects out there that aim at printing electric motors. When you look at electric mobility, there's a huge potential for that, especially since electric mobility now includes aircraft. So obviously, you need very light motors for that. So it's really, really getting into a completely new direction. If you can print an entire mechanical assembly in one piece, how would you design it? And also customization, because the printer doesn't care whether it prints the same object over and over again, or it prints an individualized object every time it goes to print. So we might at some point finally have shoes that actually fit our feet and not some generic foot that somebody engineered. And it would look the way we want it and not the way some designer created it for us. So that's another thing that we can copy from nature, right? There are no 2 flowers that are the same. And just like nature, we can now essentially customize things. The flower uses generally the same algorithm to build itself, but it self-adapts to the environment. Now, how do you design for this new world? Could we actually move the design of these new products to a completely new level by also copying nature? Now, here's an interesting project that we did at my company. These are 2 rocket engines. Usually they are bigger, but for some reason I always get into trouble when I go through customs with the larger ones. So these 2 rocket engines, they look very different from each other, geometrically. But they were actually created from the same algorithm. So what did we do? Instead of designing a rocket engine, we asked the rocket guys, how would you actually design a rocket engine? And we put this into an algorithm. And then we fed it with data. And then we added a simulation. And the simulation's task was to kill all the versions that didn't work. So essentially, we were trying to do evolution in the computer. And we didn't generate 1 rocket engine or 2 rocket engines. We generated 2 million rocket engines. And then we killed all the ones that didn't work and ended up with these. So it hasn't flown yet. We are not sure if it's actually working, but we're getting there. So this is a completely new form of design. Imagine if you captured the DNA of your shoe and it would self-adapt to your foot. This is the world that you are getting into. Now, I want to wrap up here because we have some wonderful examples coming from Alex, who will show us some of the stuff that they are doing at his company. But I just want to leave you with this incredible perspective of this toolkit that we're generating right now. I think this is extremely significant. In terms of significance, I think it's very similar to what happened 60 years ago when the microchip was invented. If you think about it, 70 years ago, computing machines were like these big industrial things, electromechanical devices that were had only very limited purpose. And then somebody found a way to print this on a wafer, on a silicon wafer. And this started the computing revolution. And at the beginning, people were like, oh, I don't know, what should we do with all this computing power? You know, how many things can you calculate? Well, by now we know that you can calculate a lot of things and you can create a lot of stuff once you have this technology. Now, we are headed there now in the same direction with all of manufacturing, now that we can 3D print almost anything. And I will just give you like a final impression of some of the amazing machinery that we have around here, you know, outside of the human-made world. And where can we now go that we are approaching the complexity of nature? I think it's really, really interesting that this technology comes at a time when we have tremendous challenges as humanity and a lot of things that we need to solve. And I think it will dramatically improve our capability to solve these issues. So please join me in welcoming this panel, and Alex will give a little talk about, you know, the stuff that he's doing in this field, because I think it's one of the least talked about things that is extremely important in the near future. Thank you very much.
So very welcome to our panel here. My name is Alexander Gerfer, or short form Alex is eventually easier to remember. I will guide you a bit through these things of 3D printing, additive manufacturing, how I do see it, how do we see it. But first of all, allow me to give you a short introduction about our company, because mostly we're unknown. And then I go a bit into the detail of why do we go into the things of 3D printing, and I have a lot of examples to show you and some statements which are brand new from last week's conference in Berlin. So we belong to a bigger group, Würth Group, which is well known for fastening technology, a German company, privately held, and Mr. Professor Reinhold Würth still the owner. And it's now about, and that's a very interesting stuff, is about 410 companies worldwide. So by mother nature, we are divided into smaller companies to be agile, to be acting fast, make decisions fast, like startups more or less. And in 1993, we were funded in a garage in Germany, getting 100,000 Deutschmarks. So to build up a new business, a business of our Würth Electronic. And nowadays we are a group making passive and active electronic components. We do the manufacturing of these components globally, and nowadays with about roughly 6,700 employees in 50 countries of the world. In Singapore, we are here more than 13 years with our own foundation of a sales office for Singapore, now 11 years. So what we do is we make electronic components, we produce them, we make them available for all of our customers, and I can tell you which customers we don't serve. That's easier. It's not Apple, it's not HTC, it's not Huawei, so no mobile phone maker. We serve all the other customers beyond that point. Make things available, and that's very one important point for us, because that's what's needed in the market. We do it globally. Wherever we find a design manager, design electronics guy, we go and support him making his things to work. And what does it mean? That's our components on a printed circuit board, so-called. That's components nowadays traditionally built, automated or manually or semi-automated. So what do we see is coming along? Along is coming changes in markets. So what of these components could be replaced in near future or in the future by eventually automated processes, not by nowadays production lines we have? That's what drives us, and it drives us into thinking more about 3D technology. Because we live from customer service nowadays in traditional ways. We go visit customers, we give samples physically to the customer, we send them by post or by DHL or whatever, UPS, FedEx. So it's the traditional way of doing business, visiting, supporting, sending goods. But what could eventually change over time when we think 3D technology comes into the game? That's a bit of our challenge for the future. So what we did is we did actively go in this field, and we founded a so-called 3D competence center, 3D printing competence center in Berlin, where we look into all of these emerging technologies. We will listen to some of these and hear more of you, also from NTU, about upcoming technologies. And it's, as you mentioned before, it's starting with very simple plastic printings, yeah, more for toys, but we are far away from there already. We are in the high professional part of 3D printing. So what would it mean for us? Nowadays, we use it already for making design thinking support. Customers come to us and they're not happy on the existing components. They ask us, can you change this component for us? In the old days, it would mean we had to build toolings. They cost a fortune, to make it to a functional sample. And nowadays, we can say no with 3D printing and even metal printing. We can make customized, tailored, custom pieces in a certain amount of time and give these samples for further testing to our customers. And that's already true for the electronics components field. In general, we are talking about printed electronics. So we find it already enclosures getting also traces for conductive material where we can solder pieces on. It's even getting more interesting later on the field of wearable electronics. Then we see, and that's for us really the challenge, how can we, if you're a technical expert, how can we print a copper winding, because it was material-wise also not so easy to do. So how can we print 3D copper windings? It's an example here, just published last week from the University of Nottingham in UK, that they made this working. But the next step is, how do we combine this? Because now in our additional process, we would say how to now manage to build around the so-called core material, because we need two materials minimum to make it to a functional component in our electronics business. That's the challenge for additive manufacturing nowadays. We can print some structure like this, but now how to combine it with different materials, different physics in behind, material physics in behind, but we are on a good way here. We have also seen from Volabo a thing where they also print now a motor. They presented it last year on a conference in Germany. In general, anything what could be 3D printed is interesting for us. It makes it possible to print new electronics in ways we never saw them manufacturable as before. Then we have seen here also things in the term of medical devices. Nanoveins can be printed nowadays. So 3D printing technology is going from very small scale to medium size, and now even shown in the German TV and developed from Technische Universität in Munich, 3D printing cement for buildings. So when you look, this is really a big printer, but now you build out of this with cement building constructions. And as mentioned before, I only print there where I need the structure to be. Don't use too much of cement. And what was shown also is from the German TV in Dubai, they printed offices within 17 days, just published or shown in the TV this week. So 17 days for printing this office sites here, 17 days, not weeks, not years. In Germany, we have an airport which takes now roughly 10 years to build. So this one is much more faster. So it is really interesting to see how this technique is evolving. And for us as a traditional manufacturer, we have to be really aware, and that's why we started this really, to see which technology is already in behind of you, gets developed. We don't want to be overtaken, like on the highway in Germany. We don't like this. We want to be high speed on the highway. So we want to be there. That's why we also collaborate. We want to know globally what's going on in this technique, and it's really very interesting. It's really evolving. It's really growing. And for us would mean eventually a total change of business model. And we see a lot of companies already active in the field. It's not a complete list. It's some of a small picture of companies already working globally on 3D printing. So it's a good support also for investment, right? And of course, again, for healthcare and so on and so forth, we have supported here a project in France where we give some kind of support for these healthcare devices. Many things to see. And there were two studies last week from Berlin, Digital Suite in Berlin. KPMG made a study, and there were two statements, and one statement is here, lot size one. In our production world, we talk about mass production, millions of pieces nowadays. But now there's a paradigm change, and they say in the KPMG study, lot size one in 2040 is a production standard. If you ask today and nowadays a manufacturer, can you print me one mobile phone? You would say, are you okay? Come back when you are cured from your sickness, right? Lot size 1 today is not a production lot size. No one would do this for you. But in 2040, they say lot size 1 is more or less really a standard, and due to even decentralized 3D factories. So more or less you ship only the raw materials there, and you print there what you need. They call this the land of milk and honey, the ideal case, more or less. Another statement says the goods of the daily consumption will be mostly produced by 3D printing. And we're talking about goods of daily consumption, not limited to anything. Goods of daily consumption will be mostly produced in 3D printing. That shows and enables and gives us a lot of thoughts about being active in this field. Think about what's coming along, and we invite you to listen to our discussion on the stage a bit more further on this. Thank you very much.
Thank you, Alex. So, now you heard a lot of Germans talk now. But we're in Singapore.
Yeah.
So, Chaw Sing Ho, you're here in Singapore, and Singapore has very early seen the potential of additive manufacturing. So why don't you tell us a little bit about what you're doing here in Singapore in specifically this field?
Thanks, Lynn and Alexander. So great introduction. So my name is Chaw Sing, and I basically run the National Additive Manufacturing Innovation Cluster. It's a mouthful. Short name is NAMIC. And what this office was created for was essentially to help industries adopt these technologies. And we talk about technologies related to additive manufacturing. There's a few, actually. So 3D printing is one of them. And most of you here in this audience here obviously know about rapid prototyping. So when we talk about anything that is made through a digital design and then going through a process where you have materials being put on layer by layer, that is additive manufacturing. So Singapore, I mean, we started this journey, I would say, actually behind the Germans, actually, in terms of understanding the criticality. In Singapore, for most of you who are seated here, you may know we're a very small country, very limited resources. But however, we have a very big contribution from our manufacturing sector to our GDP. So it's about 20%. And some of the industries that we are quite prominent, especially like aerospace, we have like 25% of the MRO market supply in Asia Pac. In the maritime space, we're one of obviously the major transshipment hubs. We actually own about 55% of the oil rig, jackup oil rigs in the world. 7 out of 10 of biomedical companies, global companies, are based here in Singapore through the regional HQs. We have also semiconductor equipment. In fact, 20% of the semiconductor equipment is actually produced in Singapore. And of course, through all these major sectors, we have a lot of these SMEs, small, medium enterprises. I think German called Mittelstand. But we are much smaller than those $1 billion size Mittelstand. But these are the 10 to $250 million revenues. And basically, they do a lot of work with these major multinational companies that support these local sectors. And one of the things that we recognize that as a Singapore, being an island state, without a natural market size like China in a region, is that we need to basically upskill our labor force. And additive manufacturing, arguably one of the technologies I feel personally has the capability to enable that, to bring innovation, to reinvent the skill sets that the workforce of tomorrow require.
Yeah, but and you essentially, I mean, you just talked to some of the technologies that are big here in terms of manufacturing, the medical field, aerospace, almost feels like the perfect testing ground for initial applications for additive manufacturing. But, I want to talk briefly about, becoming a manufacturing hub for the world. What does that actually mean in the 2040 scenario? I think it's actually going to be much earlier. if you use additive manufacturing, do you actually still need these huge factories with cheap labor that we put in the remotest parts of the world and then ship containers around, or maybe do we have a different model? I mean, maybe you can discuss that a little bit, because I think that's a unique opportunity for a country like Singapore.
Yeah, absolutely. I think, well, Singapore, as I mentioned, we have limited people and limited resources. And the other part of it is that the course of business actually is rising, primarily driven by real estate prices and, of course, wage costs. So we recognized early on, in fact, I would say this has been progressing for the last 50 years. We've been actually going through a few transitions from the 60s, where we used to have textiles industries, to the 70s. We have, some of these more specialized services like oils, paints, and things like that. And then we moved on to hard disk drive. We had very large, one of the largest manufacturer of hard disk drives in the 80s, and that actually moved out. And in the 90s, we created semiconductor industry, because from a VA perspective, or value added per capita, is one of the highest in the world. So Singapore is on this, basically this mission we have to continue to push ahead, because on a cost level, we are not competitive, against our neighbors. And I think, in a way, we recognize that the only way to enable us to be relevant in this future world of 2040, where you produce basically on demand, is to basically enable some of these technologies like 3D printing.
Yeah, and I would argue it's the only way that any country in the world can be competitive in the future. Yeah, I mean, decentralized production and production of completely fully functional parts. I mean, this is a big field that you're also interested in. I mean, you mentioned 3D printed electronics. You mentioned some of the things that you're looking into. Could you talk a little bit about what you see coming down the road here?
Good. As said before, the growth is going so fast. We thought years ago it's not possible to print this 3D copper coil. It was really like, it's never ever possible. We had designs 2 years ago, which we thought we could not make them, and now we can restart this development again. Because now we see we can build this as we like it. I saw last week also a new structure of building the cores which we have to build. So this is for us so fast developing that at this time where we are right now, we are really consuming networking to find out where is the material development going, where is the new production technology going. And of course, if we could centralize, from centralized factories go back to decentralized factories, it would help us a lot. We ship so many things around the globe, which is of course consumption of energy. It would help us a lot to really make it there where it is needed. And if we could produce it on demand, it would even save us warehouse volume. So really we could do it on demand. That would be an ideal case for us.
Yeah, if you're in the shipping business, get out.
Yeah, okay. We could ship other things then, of course. No, but the thing is really that's one of the key things. And of course, what is a big thing is actually still and still in the future is replacement parts, spare parts to print, which are not longer available by a design-driven approach. We have the 3D drawings, so why not to print it then when it's needed, not put it into a warehouse?
Yeah, it's a huge field, right? And maybe one thing to mention, that additive manufacturing is not the only game in town. I mean, we are talking about digital manufacturing, where you can combine, for example, existing electronics with the additive process to create fully functional elements pretty quickly.
And as shown by you, we make nowadays traditional parts where from my understanding, we use too much of raw materials. Yeah. Even in our designs where we could save a lot of our so-called ferrite materials, because by Mother Nature, how the field builds up, it's not needed where it is nowadays. It's because of a mechanical approach, but the 3D printing would really change the landscape fully.
Yeah, and that's from my understanding, sustainability was also a big motivation for you personally to get into the whole additive manufacturing field. Maybe you can talk a little bit about that.
Yeah, so we have one of the things that, of course, this is still very much aspirational because of the fact that the technology today is still very nascent. As you rightly pointed out, we're probably at the those IBM sort of servers, stage where in terms of the computing trend versus 3D printing. And we actually started looking at, for example, construction materials in Singapore because one of the things that we don't have basically is sand. And sand is one of the components in concrete. So what we have looked at is we've looked at, for example, geopolymer concretes where you put in fly ash. Fly ash basically is a byproduct from burning coal. So you have a lot of these power plants that burn coals, and they actually have to basically bring these fly ash to bury them somewhere. So instead, you use them basically as one of the components for concrete. Another candidate for that is glass. So glass powders, again, same thing. We have actually been working with a partner company in Australia. So they actually produce a lot of these glass products. And according to them, they were able to somehow, from the environment, through the exhaust system, capture a lot of these sand, glass powders, actually. So they were actually trying to figure out how to use and recycle these glass powders. So we are basically looking at some of these areas, and a lot of work actually is being carried out right now in the NTU, and of course in SUTD, which is the Singapore University of Technology Design.
Yeah, I was actually blown away when I came first to Singapore here and visited NTU by the sheer scale of the additive manufacturing research that's being carried out here. So this is actually very impressive. I mean, the fact alone that you use way less material in 3D printing, it makes it much more sustainable.
Absolutely.
But you can also use more interesting materials, because you can structure them differently. This is extremely exciting. Yeah. Where do you see, for your company, the biggest area where you could invest, not in prototyping, but in serial production in the near future? And where do you see the first steps, where you think this is going?
We are challenged really in the field of building up new kind of magnetics, so-called inductors and transformers for gallium nitride, silicon carbide in the semiconductor field. This needs a totally new approach of designing magnetic cores and then directly combine it with windings. Really, that's nowadays our actual thing for the next 2-3 years. But I guess it's going even faster, I would say.
Essentially, if you have like complete freedom where to put the copper atoms, how would you design the components that you're currently manufacturing?
Correct. Yeah.
Yeah.
So I mean, really from your drawing, you could really translate it to 3D printing and not limited by normal mechanical limitations you have normally in a production. I cannot make a tool unlimited in terms of how to make it working with material here, material not there. So with 3D printing, everything is nearly possible in this case.
Yeah, I mean, it's a little bit like software. If you can imagine it, you can build it, and then it's there, right?
I was thinking a few days before, and you had, as a saying, everything what can digitize gets digitized. Eventually, it's the same. Huh? Everything what can get printed will be printed. Eventually, that's our future.
I mean, we're so held back by the current limitations of the mechanical processes and manual processes that we use in the building process. So, yeah, I mean, what's one of the most exciting projects that you've seen coming out of all the Singaporean research?
So we actually, we've done several projects, and I think one that comes to mind, which is obviously not some of the industries I mentioned, is actually for space industry. So we were basically working with this Australian startup called Gilmore Space Technologies, which actually recently announced Series B funding, 14 million. So what we did with them was to create a customized 3D printer that could print wax fields in a certain kind of geometries that allows it to reduce the cost of putting a payload up in space. So that's one of the, I would say one of the things that we think actually 3D printing has a huge potential in space exploration in industries where you have to, you have to go to a planet and you have to mine the materials there, use the materials on site, and then print whatever you need. In fact, NASA, as probably some of you would have heard or read, is already doing some of these projects. They have been curating ideas around the world. And I've seen some very crazy prototypes. Actually, it looks like science fiction, but they are actually working. So I would say in the next 5 years, we would probably see some of these 3D printers up in the sky, doing stuff. They already have one in the space station, I believe.
Yeah, the company that produces this is aptly named Made in Space Incorporated. So it's their eventual goal is to mine stuff in situ and then produce objects on site, from an asteroid or from moon dust. It's amazing. Yeah.
Absolutely.
And it sounds like science fiction, like you said, but it's actually working. Yeah, amazing. So any space-related projects for you guys?
Not yet, no.
Not yet. Not that you're
But
aware
for
of.
us,
You know,
it's really the component gets fully printed, or the
Yeah.
full functional system of a PCB board, as as shown before, would be printed with everything on it. That's the ultimate.
I mean, there's this famous story of Steve Jobs. You know, when somebody told him, you know, they can't make the phone smaller, he dropped it in a bucket of water, and there was air bubbles coming out, and he said, "See, there's still space in there." So you're basically getting there, right? You know, if you completely 3D print the whole thing, you can make it as compact as possible. Yeah, I mean, there's even, you know, projects where 3D printing batteries, you know, is being researched. So this is quite interesting. Yeah, I mean, what I also find very interesting is all the research that's being done in the medical field. You know, I mean, of course, prosthetics, you know, implantable stuff, but also bioprinting.
Absolutely.
Right? And you know, I mean, the example of the heart valves last year blew me away because I had really never thought about it. You know, a heart valve is like a really passive thing, but it's currently, I mean, you can get replacements, but they are made out of plastic, and of course, your body doesn't really like plastic stuff inside. So, you know.
Absolutely.
You just print it out of your own body cells, and there you go. Yeah.
Yep.
Are there more projects like that in your university?
Yeah, I think so. We cover basically the spectrum across all the research translation efforts among all the universities, and that actually includes the polytechnics and research institutes as well by A-Star. And the biomedical portfolio actually is one of the largest. Yeah. So you mentioned some of the interesting examples. We are actually working on basically tissue engineering in skin printing, because I think most of you are fully aware, you know, testing on animals has been sort of banned or at least discouraged in most parts of the world. So there's a lot of startups that are coming up, basically using this technology, bioprinting, to create synthetic skins. The challenge in bioprinting right now is basically creating vascular structures, which is like blood vessels. So that's the part that is, I would say, is challenging. But I would say there are already some folks that are already making some good progress in that space. And the implant, personalized implants like hip joints and knees, and even you know, low-hanging fruits like shoe insoles, you know, pre-surgical models. In our conversation with you know, a lot of doctors and clinicians, in fact, pre-surgical models, the fact that they have something in their hands to look at it, to plan the surgery ahead of time, is actually gives them a tremendous improvement in terms of productivity, because it shortens their surgery time, improves the patient outcome, which is one of the key things as well for you know, aging population, especially in Singapore. Yeah. So it's something that we aspire to. I mean, in the future, maybe all major surgeries might actually require a pre-surgical model, as a, you know, in addition to MRI scans and CT scans, for example.
Yeah, I mean, talking about customization, I mean, it's the ultimate field where obviously you need customization.
Absolutely.
Well, we are out of time. I think, again, you know, this is one of the most exciting technologies that most people are not aware of, so watch this space. Thank you so much.